Hi everyone, thanks again for joining us. My name's Hunter Terry again. I'm a coordinator at the Southeastern Center of Robotics Education. This is part 2 of our series on getting started with best robotics. If you haven't already watched part 1, there's a link in the description. Go back and check it out, and you can pick up back here after that. This video is number 2 out of 3 in the series. In this video, we're going to talk about how to connect several different components of your best kit. We're going to talk about the way you connect to program it, things like that. And I'm going to try and cover every base so that nothing is left out and everyone is familiar with how to connect things. So before we actually get started connecting things, I kind of want to draw it out because when you see this tangle of wires on the table here, you'll understand why it's a little hard to keep up. So before we even actually put everything together, I'm going to draw it out for you. So here we have our brain, our cortex, just write VEX on it. This is what everything's going to plug into. So what we have in this particular setup, feel free to follow along if you want. Obviously, you don't have to build this little test bench I built a while back. You can just set everything on the table, make sure it's clear of fingers and hands and classmates, and you can follow along and plug all these things in. In the next video, we're going to actually program using the same setup. So I do recommend if you really want to follow along and get your hands on and learn, that's a good way to do it, is follow along. But anyways, I'm going to go through what's on the setup. So of course we have our cortex. Over here on the left, I've got 2 motors sort of facing opposite directions. We'll say there's a positive and a negative, even though, like I said in the last video, it's not a huge deal whether or not you do positive or negative. We'll talk more about that when we actually connect it. We're going to have 2 motor controllers here, and I'm just going to put MC there. So we've got 2 motor controllers. We're also going to have a couple sensors. So 2 sensors that we are going to use are a potentiometer. I'm going to kind of draw this little cylinder here, but it's got 3 wires. And then we've got a limit switch, which looks something like this. And it also has 3 leads on it. In addition to that, we're going to have the controller. Excuse the bad shape there, but you get the point. We'll have the controller. Make sure I'm not missing anything here. No, that's everything. In between these sensors, there is going to be a screw terminal connector. We'll consider it that. And in between the motors and the motor controllers, we're going to have that 2-wire screw terminal sensor. We'll put that there. So here's how we're going to connect everything. Let me grab a different color. We'll use orange. We're equal to these colors. All right, so first place we're going to start is with our motors. I already have here, and we'll look at it in a little more detail. I already have some wires plugged into the motors, but those motors are going to go, so I'm going to come around here to that screw terminal block. And then the screw terminal block is going to connect with the motor controller. Like that. It'll connect to there. Now those motor controllers have 3 wires coming out of them, and they're going to plug into the cortex. And we'll go ahead and say we're going to plug those into ports 2 and 7 on the cortex. Now our sensors, these are wired up a special way, and I'm going to go in a little more detail when we talk about them. So I'm going to leave that out for now, but I will go ahead and say that those are going to go into port. Let's see, we'll use, so the potentiometer is going to be analog port 1, and the limit switch is actually a digital port. I'm going to put it in D1. Yep. So there's that. Now another thing that we're going to do is plug in our controller to tether it, as well as get the VEXNet link established, and we're also going to talk about programming. At the end of this video, I'll show you how to plug in the controller and the Cortex to your laptop for programming, but I'm going to leave that out of this diagram for now. But we'll come back to this diagram at the end of the video and sort of review. But with that being said, let's get started. So I've got a couple things here that aren't necessarily in the returnable kit, but I put together just to make my life a little easier making this video, rather than having to solder and sit here and solder for 10 minutes in front of you guys. I have used these, let's see, I've got one over here, actually fell on the floor. I've used these spade connectors, which back when I was younger were part of the best consumable kit. So that might be something you look out for, is those spade connectors, because they will connect to the motor. That is great for testing, but I still, and I always will recommend soldering to your motor to make sure that you don't lose connections. Spades are also good for, if they're the right size, they're good for some of the sensors. However, these are not the right size for sensors. So I have some of these alligator clips to use with the sensors. So yeah, let's get started with the motors. So if you take a look here, I've already got these wires plugged in the motors into both leads on the motors. Each one has 2 wires. If you recall, the next step is the motor screw terminals. So these are these two-port screw terminals. We showed you these in the last video. That's what it looks like again. So we're going to take our small screwdriver. Hopefully you have one on hand. If not, obviously ask your teacher. There's a chance your hub might have included one with your kit. So here's another tip. I mentioned last time the tip of tinning your wires for going into screw terminals. I did not do that with these. You see I'm kind of twisting the ends with my fingers. Obviously be careful not to poke yourself, but twisting it together can make it a little easier to get into the terminal. So remember, the polarity isn't a big deal with the motors because it really just affects which direction it spins. So I'm just going to plug it in sort of straight, directly, no particular way. Now this is not necessarily good practice for all electronics. Remember that 99% of the time polarity does matter. So if you're working with Arduinos or Raspberry Pis or something in the future, or some little project at home, be careful and double check that you're using the right polarities on things. I don't necessarily recommend going all willy-nilly with pretty much any other thing, but these best robotics motors, they are very solid and robust, and the polarity does not matter. As with most motors, however, all motors are different, so I don't want to, make a blanket statement or anything. So let me just get the second one hooked in. Again, hopefully you can see well what's going on here. You have these little screws in here. You're just going to tighten it down on the wire, give it a little tug, and make sure it's secure, because the last thing you want is for your wires to slip out on game day. And another tip I mentioned was, something before a competition, right before a match you're about to go, to check is these wires. You can tighten them, which some of these aren't even tightened all the way. Give them a little tug, make sure they're not going to fall out. I do recommend that. Another tip for just sort of general wire management on your robot is there's this hole in the middle of these. I kind of stuck my thing, my screwdriver in it. But this hole, if you can find a screw small enough, wink wink, there should be one in your consumable kit that will go through that. Now be careful not to break these because these are a returnable item, but if you can find a screw that'll go through there safely, you can mount it onto some of the wood on your robot and make sure that it doesn't fly around during a match. I do recommend that if you are able to do that. So next up, we've got our motor controllers. So if you look at them, has VEX logo on it. It says VEX Motor Controller 29. Pretty self-explanatory what these are, and I explained it in the last video what these do. But again, another place where the polarity is not a huge deal. For this time, for this sake, I am going to plug it in so that the red wire is going to the red wire and the black wire is going to the black wire. And again, this is a place that's really easy to come unplugged. So I do highly, highly recommend that you tape that with some painter's tape or figure out some other legal way to secure that to each other. And I'm going to get this other one. I just took this one out of the box actually. Plug it in, and we're going to plug this in. So let's see, what did we say? We said this motor is going to go to port 2. So that is it right there. Another note I mentioned in the last video, you want to be careful about not using ports 1 and 10, but also these wires are keyed, so it is nearly impossible to plug it in backwards. Don't force it, be gentle with it, and you'll most likely get it in the right direction. Don't stress about it. For reference, the white wire, the signal wire, should be towards the center of the brain, and the black wire, the neutral wire, should be towards the outside. So we've got those plugged in. I realize I put it in the wrong one. There we go, 7. So I've got those in. Let's look at the servo, which I forgot to put on the diagram. Let's bring this back out and talk about how the servo plugs in real quick. So I kind of draw it upside down here. So the servo has 3 wires coming out of it. And they do have a connector on it. So that servo is going to go in line with the servo power adapter, which sort of has that block on it. And it does go to a motor port. So for that one, let's use motor port 3. And if you remember correctly, there's sort of 2 banks of power for the motors. So port 3 is going to share that power bank with our left motor here, or bottom motor, we'll call it. So keep that in mind when designing your robot and picking which port to use. It is going to share power between ports 2 and 5 and ports 6 through 9. So I will plug the servo in now. The servo power adapter is actually male on both ends. It doesn't matter which end you put, but do be very careful about polarity on these. It does matter. They're not necessarily keyed to force you to do it. They do have keys on them for plugging in the brain, but the keys on these do not force you to plug it in correctly. So be very careful that the colors match up here. You've got a black, red, and white, and they do matter for the servos. So I'm going to put that in port 3, like I said, and I'm going to set it sort of right here, and we will get to that later when we start programming in the next video. And so that leaves next our 2 sensors. So this is the potentiometer sensor. You may have also heard it called a pot sensor. Back in the day, that was a pretty popular term for it, but I'll stick to potentiometer. It's got the spinning knob on it, and it's got 3 wires. So now I want to show you real quick on this board how to wire the potentiometer. So when you look at it, I'm going to kind of draw it bigger next to it so you can see. You sort of got this sort of gravestone shape. And you've got 3 leads coming out. Of course, you've got your knob right there. So these 3 leads all go to 3 different things, and I'm going to double check so I don't tell you the wrong thing here. So I hate doing that, and I do it all the time. Okay, so you're going to plug your ground pin, your negative pin, to the left one. Your signal pin is going to go to the middle, and your positive pin is going to go to the right. And just as a reference, the way you tell that is this cable that you plug into the brain has 3 colors on it. I've probably mentioned it several times in passing already, but you've got the black wire is the ground, the red wire is your positive, and the white wire is your signal wire. So essentially what that is the black and red wires give it power, while the white wire gives it the signal that's going to be used to tell it what to do. So let me use, I was going to use alligator clips for this particular one. For this particular case, ignore the colors. I didn't have a white alligator clip to use. But we are going to start by sticking them into the screw terminal. I'm going to twist these a little bit. Again, I do highly recommend that you tin the tips of your wires with solder before you put them in the screw terminal. It saves a little bit of pain and heartache. So I do have one red wire, and I can at least keep track of the positive. I'm going to put the red wire to the red wire. Tighten it. And then we use a black ground. We use this thick black one for ground. So I'm already having a little trouble because it's not soldered. But check on it, we're good. And I'll get this third one. So this thinner black wire will be our signal. So one thing to keep in mind, this is sort of twisting wires a little bit. You know, if you were putting your potentiometer straight up to it, it's not going to be a direct match. But just remember that middle wire signal and the outside are ground and positive. Direction doesn't matter as much. Kind of like motors, your negative, positive are just going to change which direction is positive. So if you do the left as ground and the right is positive, if I remember correctly, the convention is that spinning clockwise will increase the value. Don't quote me on that, but I think that's the case. So I'm going to go ahead and put our signal wire, clip it to that middle pin, put that positive wire on the right, and ground on the left. So we've got that plugged in. All we have left is the plugging into the brain. Like I said, that's going to go in analog port 1. Again, I'll say it again, these are keyed, so you can't really, without breaking something, plug it in incorrectly. So just be gentle and be patient, and you'll get it in there. All right, so now we're going to do the limit switch. I'll grab my board, sort of show you how the limit switch goes. So when you look at it, you've got this sort of black square. Side note, the limit switch does have these 2 holes. If you have a screw small enough, you can mount it. And that's really just the preferred way. But you've got this little metal piece that comes out and pushes the switch that's right there. But you have 3 connectors. So the way limit switches work, you sort of have 2 options. I'm going to tell you the one that I prefer, just because it's a little bit more straightforward. And that is you're going to use a ground wire and a signal wire. You don't actually need all 3. So I'm going to put the ground wire on this right side and the signal wire on the left side. And unless I'm messing up and I'm wrong, which I will tell you later if I am, that's going to make it send a signal when the button is clicked. So we've got negative there and signal on that far left end. So just like the potentiometer, we'll get those plugged in real quick. So I'm already starting to get a mess of wires here. I don't recommend your robot looks like this. There's nothing wrong with it as long as everything's secure and works. But I do highly recommend doing a little bit of cable management. It can save you a headache in the long run, but certainly not a requirement. Now, if it is bad enough and dragging you on the ground, it is likely that your robot inspector at your competition might say something, and I'm sure they will give you some recommendations on what you can do. Worst case scenario, you always have painter's tape, and you can sort of fix that last second. But I do recommend spending a little bit of time on your cable management. So again, I'm going to put signal, ground the black wire to that far right side, and red is hooked into the signal on the left side. Now I'm going to plug that in. It uses a digital port. That's going to be digital port 1. Got it. Okay, so that is all of our device's hardware, but I also want to take a moment to show you how to connect your Cortex and your brain. So before we start, I'm going to make sure the brain's turned off and plug in the battery. The very first time you get your returnable kit, you need to take a moment to tether your brain to your Cortex. Your controller to your Cortex, because it is very likely that it's not already done. Doing this just makes sure that when you plug in the wireless keys, it's going to connect to each other. So that is something that happens sometimes when in the middle of the season, you might upload a program, it stops working. I always recommend one of the things is plugging in your Cortex and making sure they're tethered. So we're going to use one of those USB to USB wires. They should be orange, but not necessarily. I know different hubs have different suppliers and things like that. But it's simple. You plug it in the controller, plug it in the Cortex, and then you're going to turn both of them on. I'm going to turn the Cortex on first. So this status light, we already connected and it's running a program, so just ignore that. But this status light, we get 2 green lights, means we're connected. That solid green VEX net means we have a solid connection to the tether. So now what I'm going to do is I'm going to turn those off and unplug that USB cable. I'm going to actually double check that our wireless VEX net keys work. So those fit in there nice and snug. They have little clips to hold them in. Once you have them plugged in, you can turn them both on. Let them connect. See these flashing yellow means it's looking, it's searching. Something we always see at the beginning of matches. Once we're connected, it's running that program that happened to be saved, but you can ignore that for now. So yeah, we're connected. I doubt that program has any control on it, but as you can see, we are wireless and we are connected. As far as programming goes, I will show you that as well. So programming with the controller, there's 2 different options. The one I recommend and the one that I just feel most comfortable with, and I think you might too, is it's a little complicated and there's a mess of wires, but I am going to show you. So your returnable kit should include this programming controller, your programming adapter. This block is going to go between your computer and the controller. So I've already got a USB over here plugged into my computer. I'm going to hook it into there. You'll see that light turns green. It's connected to the computer. The drivers pick it up. And then your controller has this program slot on the back. It looks like an Ethernet, but it's a different size. It's closer to a phone cable. So we're going to plug that in like that, and you'll see the joystick is not on, but it is connected. VEXNet is picking something up there. So the next step between those two is a USB cable to the VEXNet, the Cortex. And I apologize, this is a mess of wires, but it's just how it is. So once we connect those, we can turn them on. and it's going to run that program. This red light means the robot's battery is getting low. That's fine. I've got another one that I'll switch over for the next video. But this is the general plugin, and I'm going to draw that out real quick before I end this video to make sure you understand, because again, we have a huge mess of wires here. So let me just set that to the side, show a little bit, and I'm going to erase this. So the general scheme here is you've got your brain, you've got your controller, and you've got your laptop. So if you're programming the way I just told you, you're going to plug, switch colors, you're going to plug your laptop into the programming adapter, which is this little box, this orange and gray box with a button on it. That is going to plug into your controller's programming port. Your controller is going to then connect to your brain using USB. So that's USB, and this is that programming cable. Hopefully that makes it clear for you, and hopefully you were able to follow along and get everything hooked up. If not, feel free to go back, slow things down if you need to. Yeah, so that concludes this video. The next video, I'm going to show you how to write a simple program using RobotC and sort of get acclimated to RobotC and download programs, update your firmware, things like that. Thank you again for joining us. I hope you learned a lot, and I will see you in the next video.